Hello, everyone. If I can get everyone's attention real fast, we're gonna get started. All right. Thank you, everyone. My name's Ben. I'm the organizer of this meetup. This is the second meetup we've had and generously hosted by Ibotta. So can we give them all a round of applause? Really awesome office. Way better than the basement we were in last time. So I've seen a lot of new faces here. That's really exciting. Really excited personally to see the growth of the data engineering community here in Denver. I think we've been around as a group for all of 2 meetups. We had 85 people RSVP. We had 260 people join the group so far. And we have some awesome representation from some very cool companies, Snowflake, Qubole, and Ibotta. So I'm not going to spend too much time talking. We do have 3 awesome presentations tonight, and then a panel discussion, kind of free form, where you can get kind of your questions answered if you don't have time for them initially. So without further ado, I'm going to give it to Matt Feldman, who's going to be talking about modernizing data platforms.
Thank you, Ben. Thank you. All right, so before I get started, I have to ask, how many have heard of Snowflake? Raise your hands. Holy cow, okay. That's fantastic and unexpected, actually. So as Ben mentioned, my name's Matt Feldman. I'm the regional director for Snowflake Computing. I'm based here in Denver. I've been with Snowflake for about 3 years. So when I first asked those questions about 3 years ago, not one of you would have raised your hand. So it's a good sign for us, and it's an exciting time. So I'm going to talk about modernizing data platforms. When it comes to data warehousing is ages and ages and ages old, right? And database technologies. And how do you utilize new technologies that are available to you today, to your benefit? It's something that's coming up constantly, and you all understand, better than anyone, the explosion of data, right? Whether it be data sources, whether it be data types, data volumes, etc. Everything is exploding and changing almost on a daily basis. So we'll kind of walk through, what modernization looks like, in our eyes, and how it, could potentially benefit your organization if it's something that you're going down the path with. So, first you want to look at, what makes up your data landscape, what makes up your data environment, right? And there's really 3 key things. What makes up your data environment are the people in your organization that care about the data, that use the data, that consume the data, that curate the data, etc. Then you look at the data itself, right? And then you look at the applications that are consuming that data, that are curating the data, that are creating the data, right? And when you first take a look at the people in that, in that environment, right? It's probably, your environments as well, can be divided. Right? What I mean by divided is the people that, store and curate the data can be divided with the people that actually analyze the data. The people that, want to upgrade the data platform are divided from the people that actually pay for that data platform. The people that get the data are divided from the people that need the data yesterday, right? How many, people within your organization say, I need real-time data. I need the most up-to-date data now. Well, that can prove to be an issue, right? For depending on your tool sets and depending on your skill sets and whatnot. So there's a big division within the people of the organization because everybody wants something different, right? And then you look at the data itself. The data is disparate. So you're going to have semi-structured data. You're going to have structured data. You're going to have data in different data marts, right? And truly siloed. You may have an enterprise data warehouse, right? You may have customer data, internal data, sales data, etc. Right? So it's all over the place. And so this, again, creates problems and creates issues. And then you look at the applications, that house and store and give access to this data, right? They can be difficult to manage. They can be extremely expensive. They can be rigid and hard to scale. Concurrency is the, never-ending problem that organizations face, with their users and workloads, right? So these are all problems and issues that organizations, that you're in are facing, right? And facing on a daily basis. And now we're starting to see new challenges that are coming coming to bear, right? The challenges of maintaining cloud applications versus on-prem applications and systems. The challenge of expanding into new products, new markets, different environments that create those challenges. And then, like I said before, everyone wants the data yesterday, right? And so looking at real time and what real time actually means to you and your users and your organization can be a whole nother topic, for another day. But again, these are challenges that you guys are facing on a daily basis. So you need a technology that can kind of connect all three of those aspects: the people, the data, and the applications. And what's available to us today is the cloud, right? To be able to connect those three aspects of your data environment. And so in order to do that, you look at different areas, in an evaluation or that you want to bring to bear within a modern data platform, right? The first is you want to look at, making sure or at least incorporating some sort of complete SQL database, right? That's based on ANSI SQL. How many in the room know SQL? Exactly. It's the most commonly used language that everybody knows, right? And so make sure that your data platform is based on ANSI SQL, because that's what everyone knows. That can do your full DML, your merges, updates, deletes, right? And analytic SQL in that as well. And then look for a solution that has a broad ecosystem. One of the things that you don't want to do is disrupt the skill sets that your current teams have. You don't necessarily want to disrupt the current tool sets that your teams use, right? We're here with Qubole today. If your teams know Qubole, why make them change? If they know Tableau, if they know Looker, if they know Informatica, if they know Talend, why make them change, right? You don't have to make them change just because you modernize your data platform. And then look for a system that's highly available and then obviously highly secure as well, right? So these are key aspects in a complete SQL database or data warehouse that we think you should consider and look at. And then manageability, right? Manageability and the maintenance of a database has been the Achilles heel for a lot of organizations because databases are inherently difficult to manage, right? You have to constantly tune them. You have to optimize them. You have to pull every knob and lever that you can to make sure it's performing in an optimal way. Well, what if you didn't have to do those things? What if you had a solution that just worked, where you didn't have to manage indexes, you didn't have to manage vacuuming, you didn't have to manage partitions or sort keys or do data distribution? If you didn't have to do those things, your teams could focus on the more value-added activities for the organization, figuring out the right questions to ask of your data rather than poking and prodding your data warehouse or database for the right performance, right? So think about that. Think about what that could potentially do for your organization if you could eliminate the need to do these tasks that you see here. Kind of different. It's different than what most people are used to, right? When we say that you can have a solution that you don't have to manage indexes, you kind of get the tilted head going, well, what? Well, I've always managed indexes. Why would I not want to do that, right? So it's an interesting thought. And then a solution that can consume and ingest all of your data, right? Obviously, you have structured data in the environment, but now we're just seeing an explosion of semi-structured data within organizations, right? When I say semi-structured data, it's JSON, it's Avro, it's XML, it's Parquet, it's ORC, et cetera, right? So if you could have a solution that you can ingest not only your structured data, but your semi-structured data into one data platform, so you don't have to manage multiple environments, that can be powerful. It's truly modernizing your data platform, right? We've seen an explosion of Hadoop, and that was really meant to manage semi-structured data, right? Your non-relational data. But it's an interesting thought if you could combine your non-relational data with your relational data into one performant platform, okay? And then concurrency has been an age-old, problem. We've talked about this where multiple workloads are trying to access a finite amount of resources and they butt heads, right? How many times have you as data engineers or other practitioners gotten phone calls saying, why is my report running slow? Oh, sorry, it's because we're running an ETL job or a data load at the same time, right? Again, a few laughs. It happens all the time, right? And so now with the proliferation of the cloud, you now have elastic resources at your disposal to separate workloads from each other and give them their own sandbox of compute, if you will. So that workload doesn't affect anyone else's. You can have near endless concurrency, with an architecture such as this. And then paying for your database is always a touchy subject, and the expense of the database. And I need more resources. I need to scale. I need more storage. I need more compute, right? It's an ongoing discussion. With the cloud, you're afforded very affordable storage, right? And compute resources. And so you should only have to pay for the resources that you use. I think gone are the days of, the old, Teradata boxes and Atiza boxes and these on-prem hardware solutions that come with a really, really high dollar amount, right? And a finite amount of resources, right? There are solutions out there that are truly only pay for what you use. And so you no longer, I think this is a funny analogy, but you no longer have to size your church for Easter Sunday, right? So now you can scale up, you can scale down, and truly only pay for what you use, right? Again, use modern technologies that the cloud affords us, to bring this to bear. Something that is a hot topic now, I think more than ever, is sharing data with other organizations, sharing data internally with different departments, and sharing data with partners and customers even, right? And that becomes a very difficult problem. Most people, most organizations either share S3 credentials, they're creating FTP transfers and things like that to share data. Well, there are options, again, utilizing the cloud to be able to share data effectively, securely, and efficiently with internal customers, external customers, partners, etc. Right? And so what you have the ability to do is share that data out, and you control who has access to it and what they can do with it. Right? So again, it brings that flexibility for you to create additional revenue streams, closer partnerships with your partners, give more insight to your customers, etc. Again, the cloud affords us those options to be able to do that now in a really flexible, secure, efficient way. This is possible with a brand new architecture, right? In the middle there, you're afforded very flexible cloud storage now, right? Whether it's AWS, whether it's Azure, whether it's GCP, you're afforded very cheap storage, for lack of a better word. And then you're also afforded elastic compute resources that can turn on, that can turn off in a matter of seconds, right? Again, the cloud allows us to do that. And then you wrap that in as a managed service. So those management tasks that we talked about, no longer are things that you have to do or your team has to worry about because it just works. And that's all wrapped around, that managed service, right? So again, it can create a different way that you look at the data, a different way that you potentially monetize your data. You present insights to either internal customers or external customers. If you now have the flexibility to worry about the questions that you ask of your data, rather than poking and prodding your data warehouse, trying to scale your data warehouse, trying to do your 3 to 5 year plan of how big is my data warehouse going to be. And now you can really focus on really what matters, and that is the actual data. Right? And asking the right questions. So I'm going to share a customer story, a customer scenario, and that's our local customer here, Return Path, and kind of share, a before and after and some of the results that they've seen. So the before, or I should say the scenario that they were looking to accomplish is really creating an affordable, scalable, performant, platform where they can aggregate all their data, right? They had, disparate, silos of data here and there, and it was very difficult for non-technical users to get access to that data, analyze that data, et cetera. So some of their pain points were what they currently had was extremely expensive. It wasn't very performant. And then they had challenges integrating all their data sources into one single source of truth. And the solution was to look at Snowflake and to be able to do that. So the situation before, from a performance standpoint, was that some very basic analysis was taking them 1 to 2 hours to run in their current in their previous platform. Right, they were burdening their clusters. Right, so everyone was trying to access, via these clusters, and they were overburdening them. So it was taking forever for these results to return. It got expensive, and like I said, their non-technical users had a very difficult time accessing the data. So now with Snowflake, being able to give them a flexible, scalable architecture at a very price-efficient model, they were actually able to realize 120x gain in performance. So what was taking them 1 to 2 hours was now taking them 1 to 2 minutes to be able to do. There's a lot of value there to be able to get those results faster, because then you can iterate and iterate and iterate without having to wait 1 or 2 hours before those iteration cycles. They were also able to get that data in front of their users faster as well, being able to load data at the same time as everyone was querying the data and having no effect on each other, right? Again, really, really powerful. And the ease of deployment was a huge, huge benefit for them. The ease of migration from previous to future was a rather seamless process, and it wasn't overly burdensome to the teams to where they didn't have to take any downtime. Right? So again, the business results that they found were incredible, because what it took them to do in a week or two, they can now do in a day or two. Right? Really, really powerful results. Something that I wanted to share, being that we have a terrific partner of ours here in Qubole, is return pass architecture and how they use Snowflake and Qubole together, right? To do some of that machine learning, type work. And what they do is they persist the data within Snowflake, and then they can push the process, the machine learning process, into Qubole, where they train their models, they do their featureization, and then push that data back into Snowflake, for other users to get access to and to be able to analyze as well. Again, it's shortening their time to value, and these cycles that before, took them several weeks to realize value from. So with the partnership with Qubole, they can now incorporate all that machine learning into the platform and push that featureization and model training, into Qubole, and then push the results back into Snowflake. So, in closing thoughts, around their use case, they were able to keep all their data in one centralized location for all users to access, no matter the tools that they wanted to use to access it. They could cost manage, was made really simple with Snowflake and with the platform. And then they could connect all their applications to it. Again, giving access to all those users that wanted access to the data when they needed it, whether it's technical users or non-technical users. So it was a really big win for them. And again, the results have been really, really compelling. So with that, I really appreciate the time. Thank you so much for joining us tonight. We do have some swags, so if you're ever interested in grabbing some Snowflake swag, we've got a lot of cool stickers and things like that over there. And then I'll toss it back to Ben. So thank you.
Yeah, he's not joking about that swag. They have these stickers of like a unicorn that's dabbing. So go get some of those. We're serious. Okay, so we're gonna switch sides for a second. If you want to go get a beer or some wine or anything, I'm really proud of us as a group. We're really crushing that pizza. All right, so I'll do a quick intro. Awesome job. Yeah, so I'll do a quick intro review. Just what? Yeah. Want to use your own clicker? Oh, good. Let's use this one. Use this one. All right, everyone. I think we're gonna get started with the next talk. If everyone can make their way back over. All right. Get your pizza, get your beer. Oh, wait. Are we recording? Awesome. All right. So our next talk tonight is going to be on the state of modern data engineering from John King, who's the solutions architect at Qubole. We have a bunch of Qubole people in the audience. So if you're interested in Qubole and want to learn more, you're probably no more than like 2 people away from someone at Qubole. So I'm going to let him talk and get out of your hair. So thank you, and please welcome John.
Thanks, everybody. It's been nice. It's nice to get back and be talking to no one's here. A lot of faces I know from Ibotta here. A little bit about me. I'm a solutions architect at Qubole. I've been in the big data industry for about 10 plus years now. I joined Qubole earlier this year after leading the data engineering team here at Ibotta. Before that, I was a principal data engineer and architect and manager for several data teams at companies like Ibotta, SolidFire, and Footbucket here in town. So today we'll be talking about three overview things. The state of the modern data architecture, the workflow in the modern architecture, and Airflow and best practices. So based on two research papers from Gartner and McKinsey, how many people know that 85% of big data initiatives actually don't provide the value back to their companies? That's a pretty tough statistic. And because people don't have the resources, the time, or the energy, or the money, 70% of data actually never gets realized. And that's a study by McKinsey. Data initiatives can actually be successful with a modern data platform built on the cloud infrastructure. You need a platform that can scale as the company grows data, enables you to explore data quickly and efficiently, and the ability to collaborate across teams. You don't want to be shifting data between disparate systems, moving between verticals, things like that. You want a common source of data, a single truth of data that people can access. All right, how many people have seen this? Right, that's a pretty big space for the big data landscape, and this was 2017, so it's well over a year and a half old. Qubole plays pretty much in this area: infrastructure, machine learning, cloud agnostic, as well as supporting a lot of engines across most of these clouds. Most of our customers play in this area. Right? How many people have seen these engines before? So these are pretty much the top of the engines for the different verticals within the big data industry. How many people are using one of these engines? Raise your hands. How many are using 3? How many are using 5? 10? 20? All right, Charlie. All right. So preparation, interactive analytics, right? And finally reporting to your consumers. Right? Not to mention all of the operationalization that goes on behind the scenes. How many are using Jenkins? No. Datadog for metrics reporting. Yep. So where does Qubole live within the modern data architecture? So on the left hand here, you have data ingests. So these can be your applications, your warehouse, Kafka streams, things like that. Your modern data platform, you're storing data within S3 or some object store within the cloud that you're using. Qubole is basically a work engine where you can spin up ephemeral clusters on top of that storage. So you can spin up as many Spark clusters, Hadoop clusters, Hive clusters, Presto clusters as you want. And use that for your machine learning or ETL. And then egress that out to your data marts, right, where you can connect Looker several other, your BI tools. And the nice thing about this is where we can have a really nice integration with Snowflake. Right? One of the value props of Qubole is our ability to auto scale to meet your compute needs. And it's nothing that you only have to configure the min and max nodes that you want within your cluster. And then Qubole takes care of the auto scaling for you. So what we did here is we looked at a workload for one of our customers. You can see on the left hand here, kind of a nominal state. And then a big job comes in. And we categorize our nodes based on demand, which you're paying full price for, and spot, which, how many people here know what the spot market in AWS is? How many people know that you can save up to like 80% in spot, right? So that's one of the things we do with auto scaling is we allow you to configure how much spot you're using for those clusters. Okay, yeah, I've always had a problem with that. So, boy, bunch of directions for the crowd. So, okay, so on the bottom hand here, you have your on-demand nodes. And let's say we have a 72 node cluster, right? You configure 36 nodes to be on demand, and you can configure 36 to be spot. So you're not paying for the full 72 nodes, right? You can effectively save somewhere between 50 and 75% on your work for your AWS cost, and do a lot more work for a lot less money. And so you spin up your job, we scale up to your 72 nodes. That's the amount of resources you need to finish your job. You finish your job, and we scale down. Right? No configuration. Don't have to do. Don't make me think. Right? So Qubole and Snowflake. This is a really good integration for us. Snowflake is a great partner, and when we talk about building out efficient data platforms, we want to provide. It's important to provide a holistic platform for your users. So, the ability to have a first-class integration with Snowflake, to bring data, to use data in Qubole, to egress to Snowflake, to bring in from Snowflake, to use Qubole for your machine learning, your data science use cases, stream processing, data preparation for ETL. It's really important to provide your users with that overall well thought out data platform. So the goal of the data platform is to create a data-driven organization. So how many people here have data-driven organizations? How many people are on your way to having a data-driven organization? All right, yeah. It's a tough thing, right? You need to enable your users, you need to give them access to the data, and you need to have efficient operations around that. One of the ways that most people are doing it now is through the concept of a data lake. So best practices for the data lake operation is you want to take your data feeds coming in. I'll highlight here. You want an immutable data store. Why is that important? So backup and disaster recovery. So let's say your downstream data gets corrupted. You can rebuild that from your raw store. And then you can use an engine to categorize, optimize for your end users, and push that out to your data marts. Or you can push that back into your work engine. And then connect your BI tools, your reporting tools, in-house tools back to those. And then down at the bottom, of course, you have Airflow managing the entire workflow process. All right, cool. So let's talk about the state of big data today. So Qubole has a lot of customers, and what we can do is we can look at those customers and get a very good idea of what the big data landscape looks like today. And we started this in 2017. So we looked at our customers and found that over 75% of them were using more than one engine. Fast forward to 2018, we found that that has grown to 86%. So by having multiple engines, our customers are able to find the engine that fits their best use case and tailor that for that engine. All right, so talking about like the adoption, let's go a little bit deeper in the adoption of these engines. Apache and Hadoop have been the mainstay of big data for a long time, but now Spark is coming on. Like we're seeing huge adoption across the platform. We're also seeing adoption in more niche engines like Presto for low latency data querying, ad hoc. People just want to go in and they want to look and they want to do some initial test with their data. So we're finding that people are using Presto a lot for that. And that shows by how many commands are run per hour in Presto. 24 times more commands in running in Presto than Spark across all of our users. 6 times more commands than Apache, Hadoop, and Hive. So these new engines are coming on, and they're coming on really fast. And our customers are finding that they want these engines. It's not just enough to have a scalable data platform. You have to back it up, right? And so what we're finding from our customers is we're saving 50% in their cloud costs by using spot instances, by using a smart auto-scaling algorithm. We're finding that you don't have to have as many data engineers or admins to customers. So 1 to 65, that's on average. We're finding customers that have upwards of 1 to 250 plus. Right? And you need a system that can scale with your growth without much intervention. Samsung, SmartThings, which was purchased by Samsung, they grew 10x. So you need a system that can keep up with that. The must-haves of a data platform. Realize that the cloud is probably your best bet to build your data platform for automation, and ease of use. You need to get your users more access to the data. Again, that's one of the fundamental tenets of the data-driven organization. And then movement to multi-engine. Provide your users the ability to choose the engine that best fits their workload. Right? So if it's low latency ad hoc, well, Presto. If it's massive amounts of ETL, Hive, machine learning, Spark, right? Workload optimization and use Airflow for that. So how many people here know what Airflow is? And quite a few. All right, I'll hit some high areas for those that don't. Basically, it's a task management tool. It's built in Python, so you don't have to know Java, Scala, any crazy language for that. No Clojure. Works on the concept of directed acyclic graphs. So how many people know what a DAG is? The other way that it's built in such a way that you can either scale out horizontally or vertically. So you can add more resources. You can add another instance type, move it to that, and get the resources you need. Or if you're running really big jobs, you can add more worker nodes. It's got a lot of integrations for different clouds, different engines, pretty much anything. Or you can build your own operator for that. We're seeing a very strong growth in the open source community with it. How many people know of Luigi? Yeah. Azkaban, Uzi, right? We're seeing much stronger growth in the community within Airflow. That's one of the reasons we chose it. It has huge community backing. And also looking at our Qubole users who are using it, almost a third of our clients are using Airflow in production right now. So pretty important for them being able to schedule their tasks and manage their workflows. We also use Airflow internally for our Air product. So we're doing data science on our internal data to help our customers use their data better. All right, so here's what a DAG looks like. We have some nodes on here. D is dependent on A. E is dependent on D and B. So A could be sensors, B could be waiting for database, a new data set in the database to come in. And then you can have the idea of your happy path. So the green is your happy path. Essentially, you want to get to H, correct? Right. How many people would attempt this in cron? I knew, I knew Stephen would. Right. So that's primarily why Airflow is such a great product. It's enhanced cron. You can set up dependencies upstream, downstream, and you can also have alternate paths depending on if there's an error in your DAG. So like everybody wants the green path, right? And that's what everybody develops for. What happens when you hit the red path? Right? There's a lot of operators, a lot of branch operators within Airflow that you can use to handle those. Who likes coming in the morning and having their CE go, "Where's my data?" That's when you just want to go back home and go to bed. So, just a couple items for the technology. It's built in Python. It also has a rich CLI. So those old school people that like to work in terminal like me, I like the CLI. But it also has a nice web application for monitoring. So a single pane to view all of your DAGs, everything that's running. You can see where errors are happening. You can dive into the logs from there. So really, really nice feature-rich web application for that. It's backed by, you can have it backed by SQL, which holds all of your metadata. You can also have a distributed gang of workers. So it runs on Celery. So scale out your workers to meet your workload. And then the scheduler process is essentially built on cron, so you can specify runtimes. You can use your usual cron nomenclature for that. And diving a little bit deeper, Airflow has the concept of hooks. So these are probably the lowest level abstraction of connecting with. Operators are a higher level. They use the hooks, and you can abstract the hooks away with that. Tasks are your nodes. Pools are kind of important. When we talk about being able to segregate users and work out within the cluster, like the modern day is, please don't have everybody running all the same hardware at the same time. Right? Things get nasty from that point. So you can schedule out pools and have data engineering, data science, data analysts working within those pools, and they have a set amount of resources for that. Connections, it's not just operators interfacing with other outside systems. You can have connectors that look at other databases, S3, like you name it, you can do it with that. Queues, you can also set priority for work going on within your pools. So you may have an SLT report that needs to be weighted higher so that it gets the resources it needs to run, so that when your CEO comes in the morning, he has his data. You can also set things like environment variables, which are encrypted by default. So that's really nice. If you have passwords, hashes, things like that, makes it really nice. And because Airflow is a distributed environment, you need a way to talk to different tasks that maybe run on different nodes. Right? So XComs is the way you do that. And it's basically key values that are stored in the database, and you can call them between tasks. And DAGs and subDAGs. When your DAGs get really complex, you may want to go use a subDAG to kind of abstract that away. Stay away from the subDAGs. Use it at your own risk. So what does a sample DAG definition look like? So here we have three operators that are doing different things: printing a date, sleeping, and then a template ID. So you create your operators, and then you can set dependency upstream and downstream with those. Right? And like we talked earlier, you can also have alternate paths with those. So these are just some of the basic operators. There's Qubole operators, there's database operators, if you haven't looked at Airflow, go through and look at the operators. It's quite impressive. When we talk about distributed work system, there's four execution modes: sequential, local, Celery, and Mesos. Celery is by default, so we're going to look at that one. All right, how many people are using Mesos or a container application? 1, 2. So here's kind of a high-level view of how things work within Qubole, or within Airflow on Qubole, and just a visual representation of how work gets done. So on the left here, hand side here, you've got pretty much Airflow right here. The scheduler, the DAGs, your metastore, and your web server. Okay. Your work job gets defined within your DAG directory. DAGs get sent to the broker, and then your workers pick it up. And of course, there's all the dependency chain that goes on with that. That's all handled in with Airflow. Make sense? Is anybody running distributed Airflow? How many people are running Airflow on a single instance? Okay. So one thing that we can also help with is troubleshooting and logs monitoring. There's a scheduler log, a web server, Rabbit, and Celery workers. So being able to troubleshoot this distributed environment is pretty much finding log files. They're very well versed, and they're pretty easy to find. Setting up the ability to deploy your DAGs to a server, and having those automatically merged into the production environment, right? And then it makes it really easy. You can monitor with Celery, Ganglia. You can do log monitoring. How cool is that to do big data on your own logs? It's like the self-feeding data platform cycle. Right. So the reason I show this is like when you're building platforms on the cloud, right? There's several gotchas that can happen. One of those is upgrades of your RDS database. What happens if that gets upgraded in the middle of your run? Your CEO comes and goes, "Where's my data?" Right? So you want some type of redundancy. And so what we do with our customers is we help them with HA setups similar to this. How many people have been bitten by the upgrade bug? That suck. Just having AWS update your database. So a couple of best practices is Airflow generates a ton of logs, right? And those are useful for a period amount of time. Move those off whenever they don't get useful anymore. The ability to synchronize DAGs from your Amazon S3. Like put it on S3, have a DAG that updates your production scheduler. Run your entire Airflow infrastructure in UTC, right? So there's nothing worse than like going, what time did that happen at? Right. And then if you really need, set up your Airflow with an external RDS. And if you really need it, make it HA. Thank you all very much. Appreciate it.
Thank you, John. All right, so we have like 4 slices of pizza left and a few more beers and wine. So I'm gonna give another 5-minute bathroom break, beer break. So go crush it. right. We can start moving over back to our seats. We're about to get started with some great speakers from Ibotta. Just have to go up to people individually, tell them to move over. Nah, it's fine. All right. Are you Steve or Steven? Your signature says Steven, but I tried it for you. All right. Sure. I don't know. I really. All right. So for our last talk of the night, we have Mike Lewis and Steve Carpenter, who are residents here at Ibotta. So they're going to be talking about some of the tools that we've heard of tonight, Qubole, Snowflake, and how they use them in practice here at Ibotta. Some lessons learned, maybe a horror story or two. But with that, I'll let them introduce themselves and take it away. Thanks, guys.
Alrighty, I'm Steve. We're going to start off by talking about configurable ETL using Airflow to try and automate away as much of that process as you can to try and work on more fun things. And then Mike will talk a bit about one of the feature engineering projects he worked on that is powered by that. Also, we are hiring here at Ibotta. We have a lot of job openings if you go to ibotta.com/careers. A little bit about me. I'm a data engineer here. I've been here 1 year exactly. I went to CU and yeah, go Buffs. I'm a skier, mountain biker, disc golfer, beer drinker, and griller of meats.
Hey everyone, I'm Mike Lewis. I've been at Ibotta for about 2 years. I'm on the feature engineering team. I went to WashU, studied engineering there, worked as a consultant for about 2.5 years, and then went to the Galvanized Data Science Bootcamp. Ended up at Ibotta after that. I'm also a rock climber and a rare beer hoarder. So I have more beer coming in than going out, unlike Steve. Yeah, and a little bit about Ibotta. For those of you who aren't familiar, we're essentially a couponing app. We do rewarded shopping on your phone. So our core competencies are essentially like saving people money. But in that process, we are collecting a bunch of data. We've got some big numbers there you can read. And then I'm not a sales guy.
The big one there is the $371 million we've given back to our users over the lifetime of the app. That's the important thing. So take note.
But now about the data. So we get a bunch of receipt level data from our shoppers because in order to get the reward, they're taking a picture of the receipt most often, or we have an integration with the retailer they're shopping at. So imagine like actual receipts people are getting from a grocery store. We collect all that data, which is super valuable. And then we also get some geolocation data and self-reported demographics on our users. So lots of interesting things that mingle nicely for a data science and a data engineering team.
So where Ibotta started out before we ended up with the data platform was kind of like Bobby rolling around in the dirt. Very difficult for our analysts to find what they needed and definitely not self-service. Where we are now, we're laying back in the bed, we're eating chips off our chests, and life is a lot better. So what is data engineering here at Ibotta? It is the foundation of our data platform. It allows us to support feature engineering, our recommendation systems, analysts, BI, and some stuff's now even going back into the app, which is awesome. It's really us learning how to move stuff efficiently between the data stores that we have, and we have a lot of them, and ensure uptime SLA hits, and basically the critical decision-making infrastructure that we have here. We are fairly data-driven at Ibotta. We like to make decisions based on what we know, and we enable that by having high availability of data to everyone who wants to use it.
And feature engineering at Ibotta. Our core competency is machine learning, and our mission is to enhance all our raw data assets using machine learning for various stakeholders, including analytics teams, the app itself, really just anyone who could use a cleaned up data source. We're trying to provide that for them. And we're using tools like Airflow to orchestrate our work. And most of our production jobs are using PySpark. and everything in that realm is managed by Qubole. So thanks, guys.
So a little bit about like where we started. We originally started with just a MySQL database, classic Ruby on Rails application, and that was being dumped out for our analysts to use Excel with. Quickly, we had to escalate into your classic MySQL on Redshift situation, where you end up with your entire relational database in Redshift. We managed that ETL with data pipelines, and as well did aggregation pipelines with that so that we could power Looker. This quickly became unsustainable. We had compute tied to storage, and we had this situation where one person could bring down all the dashboards for the SLT, and that's obviously a terrible thing. So we had to find a way to democratize access to that data. This is our current data platform today. You can see Airflow is in the back of it, controlling all of the orchestration. We have a ton of different data sources that are coming in on the left, and we have access to all of that through Qubole using Hive, Spark, and Presto. So eventually all of this is supported for Redshift on the other end, which has Looker. Right now we are working to put Looker onto Snowflake in the future. That's a current initiative. And hopefully one day we will no longer have a single Redshift node in this house. Currently we have two 90 node clusters. We also have data products that come out of that and go back into S3 and into external partners. And if you can see here, we have a raw staging and a default. This is a great pattern to have in a data lake, and all of this is in S3 cordoned off into buckets so that we can also control access. We keep raw in JSON. It's easy to work with for a lot of purposes, but we optimize into orc and add our own little touch of optimization to that. So this is kind of where we ended up once we got Qubole into the house. We realized we needed to split up access to our data, specifically to solve the Redshift problem. But in the course of that, we actually greatly enabled our machine learning and engineers and analysts. And we also started creating a lot more data, mainly by snapshotting a ton of our tables. It allows us to travel back in time to see what the databases looked like before, but also features like Mike built, we can do that with as well. So right about this time last year, we had about 20 terabytes of data. That was when I joined. We now have 3.2 petabytes in S3, and it's growing at a very, very, very rapid rate. So that is something to look out for, but it's also great news. So also, by the way, we are hiring a senior data engineer if you'd like to come work on stuff like that. So the big thing was configurable ETL, and it's really trying to manage my day-to-day workflow. A lot of ad hoc requests come through, like, can I get this table from Redshift into Hive? Can I get it back from Hive into Redshift? I need this for Looker. Can you add a column? And a lot of this is a repeatable process where ultimately you can boil it down to a few things need to change. And so that's the idea with configurable ETL is we can abstract away the actual ETL and just leave basically the question that the person has. Like, I want this that's located here to go over there. So when doing this, there's strict dependencies, and you can't obviously take account before you've added the data. It needs to be extensible and scalable. Some of them need transforms, some of them don't. And you need to be we wanted to try and make this as self-serve as possible. Our ultimate vision with this is that ultimately our analysts can come in and just submit a pull request, and their table is now going to start moving on a cadence. So how do we get there? We're using Airflow. This is what an actual DAG looks like in Airflow, and this is one of our configurable ETLs. The idea is that you have a large DAG, but the key component is the path. All of them have the same path, but they're all different tables. And so you're able to take this one path and do the same thing over and over again. You can have like copy commands in there to Redshift. You could have Hive, Spark, Python operations, counts, sending stuff to Datadog, Presto, all of it, and manage it all with Airflow. And we essentially use Airflow just as an orchestration engine. We don't really do a lot of compute on it. We send all of that to Qubole and to our clusters. So here's where we configure all the things. This is that same DAG, but taking a look inside the configuration file. Ultimately, what we boiled down, this is for Kinesis fire hoses that dump into S3. We learned that essentially the only thing that changes between these is the source locations and buckets, compression, start times, and what the table's called. So if you can extract away all of that, you can loop through it and create this ETL process where an analyst can go in and see the pattern here, clearly defined JSON configuration, and just add a new table to it. And that's the goal. Whether it's fire hoses, like unloading MySQL, whatever it be. A key feature here that's more technical for Airflow is that we manage our start dates in here. So you can add a new table in there and add a start date that is today or yesterday. And you don't have to bump versions and risk corruption in the database or namespace or have to update like your actual DAG name to clear that out. So it's convenient and stops Airflow from automatically backfilling when that backfill can be useful to have on by default. Ultimately, this one, 11 lines of JSON. It takes adding a new pipeline for a new fire hose. Like we recently added a new partner radar, adding a fire hose and getting all that data into our data lake, seconds, not hours or days or anything like that. Generating the DAG from a config. The idea in Airflow is you're generating objects and then linking those objects together, and that's your vertexes and nodes. And so in Airflow, you can generate from a config by looping through a JSON list once it's a list in your code, and you can interpolate in the various things from the config. And the last step that's key is inside the for loop is linking them all. This is your set upstream, set downstream, or using the operators like that. And a key is also the initiate job task and complete job task are defined outside the loop. And so they kind of tie the whole thing together. Those are the start and end you saw. And this allows us to have a way to alert cleanly at the end, but also tie the whole DAG together so it's not just a bunch of random processes. Let's see. Best practices for doing this in Airflow, always version your DAGs. At the end of the DAG name, append an underscore v1, increment that every time. Airflow stores your information about your DAGs in the database. And so when you go to change or add new task instances or a new start date, say because you added a bunch of task instances, you want to update the namespace so that it's a fresh new namespace because you're having a compound key of like DAG to task instance. That keeps things safe. Also, make sure you have an ephemeral logging solution. John talked about this a little bit. You want to clear out your logs frequently because they become useless after a little while. We use Sumo Logic to kind of export them all, but we also clear them out regularly. So you can go back and look at something that failed overnight. You want to homogenize the path from raw to production. This is a little different. We use a factory DAG for this that I'm not going to go too in depth with here, but it's a DAG that creates other DAGs so that we can have the same process for taking that data that goes into the raw JSON form and optimizing it with production standards in work. Also, pull out common code into operators. Airflow is designed to be incredibly extensible. It's really easy to go in and say, I do this all the time. Let's make this like an operator and give it its special color and all of its own error handling. The colors are nice. Also, a big one is try to only do one thing with each task. If you try to run like 8 Hive commands in one task, what you end up with is that task having to retry and have to do all 8 of those Hive commands, even when the first 7 of them finished. So if you separate that out and have a lot of tasks, it's easier to find out where things go wrong and retry only what needs to be retried.
Yeah, data engineering learned some of those the hard way too. So I'm going to talk now about a process that takes that raw data engineering put down for us and how feature engineering picks it back up, cleans it, and then creates a data product with it. I'm going to talk about sort of how the data comes in, how we train the models, and then how we deploy them in production. So here's what we're working with to start. This is a picture of a receipt. If you can't tell in the back, that's a really big receipt. And somebody got up really high and took a picture down on it. So that's really, really good for our system, except it's not at all. It's really hard to read lines off this. But essentially what we have is we have a system that does its best using optical character recognition or OCR to pull each receipt item off this receipt, which is the most valuable piece of information on it. I'm not going to talk about that process today, but the data ends up in our raw database, something like this. So you have some sort of receipt identifier, some text, which is really important, that sort of describes what the product is. This is when you're looking at a receipt, this is like that little text blurb that describes the item. And then we've got some really bad price data in this example, which was probably a phone number. We've got some quantities, and then we've got a bunch of null stuff when it comes to metadata about what that product actually is. And obviously, I'm going to show you how we fix all this because we have machine learning. You can't see it, but that's a Superman icon. Anyways, at a high level, here's what that process looks like. Again, we use Airflow because that's the theme of the night, apparently. We have several models here on the left trying to do things. We've got a distributed prediction step that we use Spark for. And then we have some ETL processes that pick up all those predictions and then stitch them all together for a final data product. So first, I'll talk to you a little bit about the training because it's kind of interesting. There are a lot of ways you can distribute things in Spark. And whenever we look at a model, we try to think about where can we get the most bang for our buck in distribution. In this brand classifier example, which is one of the pieces of this model, we felt it made sense to kind of distribute along the many, many different types of brands we might try to predict. So in the example before, we always use Yoplait yogurt as the example. So YPLT, YGRT, we have a model that's its whole purpose in life is to try to look at that and predict that that is Yoplait yogurt for what it is. So each model, each brand that we're trying to predict actually gets its own binary classifier. And then at the end, we stitch those all together in a 1VRS algorithm and try to predict what the final brand is. But for the purpose of training, we can actually distribute each of those brand classifiers onto executors. So if we have 2,000 brands we're trying to predict, in theory, we could have 2,000 executors predicting at the same time. Their feature sets are the same, so we could actually share an encoder between all of them and save some work there. But ultimately, it's sort of this map step where we're doing the training and then the reduce is saving a model object in S3. And generally, each binary classifier is something like XGBoost or a logistic regression, whatever makes the most sense. And to do this, it's actually kind of cool. We basically copied a bunch of code from sklearn and replaced any job load parallelization with a Spark map operation, which I can't take credit for. Evan on our team did that, and it's pretty useful. I highly recommend doing that if you have time. So, and then at prediction time, we have these model objects, each of these square boxes that kind of vomits into like infinity right there. Those are each a model. So we have an RDD with all the data we're trying to predict. We're sort of partitioning it, and then each executor gets a little chunk of data, gets a copy of that model object, which has 2,000 binary classifiers, and that executor can make its own predictions, and then they all get aggregated at the end into S3. So it allows us to distribute among our biggest sort of dimension, which is the data at that point. And then eventually, our Hive metastore will get updated with these new predictions. Here's how we orchestrate it all in Airflow. We have sort of this prediction orchestration at the top, which is actually just predicting on new text it hasn't seen before, since we don't need to redo predictions that have already been made until we retrain models. All those predictions get sort of this intermediate ETL step where they're aggregated together, and then the final creation of our clean transactions table is one more ETL step. And this is kind of just like an example. There's 3 observations here, but we're actually dealing with 4 billion rows of data when we do this. You'll notice, like in the initial example, there was a coupon in this table, which isn't really a receipt item. We have a model that strips that out. We've got price massaging going on here, and then we're categorizing all this metadata about the items, which becomes super valuable for things like our recommendation engine in the app or other core functionality. We're producing about a terabyte of data a day with this process. So thanks, data engineering, for providing a bunch of messy data for us to pick up and clean up. I think we're hiring. Did you say we're hiring?
Yes. We have a lot of jobs
we
posted.
get paid per slide that says we're hiring.
We wish.
That's not true.
Specifically, the senior data engineer is really what I'm looking for. So if you are interested or know someone that did this, reach out to us.
Cool. Thanks, everyone. I don't think we're doing questions, right? Or should we just save it for the panel?
Yeah, we can do some questions if there are some people who have it immediately. We will also be doing a panel after this where you can also ask questions. But if your question is if they're hiring, they are. So
yes, we are.
Do I have a question, or is there? Okay. For the live stream.
Hi, Mike. I'm Sanjoy. So my question is, are you automating the feature engineering, or is it something you are doing manually for every time you get a new data?
Yeah, we certainly automate as much as possible. There's only a certain extent you can automate, but we do try to create systems that would allow us to add features with configuration when possible. But yeah, most of the time a human has to kind of decide what's the new feature we want to build and go build it to start. And if there's a general framework, we'll try to build around that.
The question was for the OCR, do we like Windows 3.1 or 3.2?
I don't know what you mean by that. Like Microsoft Windows?
That's not our job.
Yeah, unfortunately,
we don't know about that.
We'll save the rest of the questions for the panel. So let's give them a round of applause. All right, so just give us like 2 minutes to set up the chairs, and then we'll wrap this up with a roundtable discussion.
Absolutely. I think the slides should be available. I'm surprised. I thought that was going to go over.
I'm sorry. What's your? I forgot your name.
I'm Steve.
Steve. Wonderful presentation.
Awesome. Thank you. I feel like I started talking a little too fast. We'll have the slides out. So
Okay.
go back.
Will it be the meetup? Will it be in the meetup?
Yeah. Ben will send them out.
Okay.
I don't really have the powers to do that, but he certainly does.
Okay.
Awesome. Headed out?
Yeah, I'll head out right now. I was just listening. Yeah. Absolutely. Yeah. I enjoyed right now, but I'll be back for the next one.
To be honest, can I add this?
If I could have all of the speakers come up to the front, grab a seat. John King, come up here. Matt Feldman. All right. Anyone from Qubole, Snowflake, Ibotta who's going to be participating in the discussion, please come to the front. John King is dead. Can John King hear this in the bathroom? Oh, there he is. Hey. Yes. Yes. Speak great.
Test, test.
All right. Hello? All right.
I saw you guys slip some extra tips in there. What's that all about?
All right. Everyone's got their drinks, got a seat. Ready to get started? All right. Cool. All right. Thanks, everyone, for coming. We're going to wrap the event up with just group discussion with all of our speakers and also a mystery guest who has not been introduced yet. So, Holden, do you want to give a little brief intro to yourself?
We've gotten them.
Yeah, I'm Holden Ackerman. I'm with Qubole. I actually used to be counterparts to Matt and now run our developer marketing over at Qubole. So do a lot of cool things, just kind of building up our open source communities Getting in with the astronomer guys over here who are a really awesome company. And honestly, you guys should check them out after this event if you're doing anything with Airflow. They've got a bunch of great, getting started guides and other, helpful resources. So just, focusing on how we can really build a nice, robust community and all, float up together. So that's kind of my role now. Yeah.
Thanks so much. Yeah, quick plug for Astronomer. We didn't ask anyone to talk about Airflow tonight, but we are happy they did because that's exactly what we offer. Managed Airflow, check us out at astronomer.io or on Twitter at astronomer.io. Okay, so first question. We got a few questions when I first sent out the meetup invite. We asked everyone to submit some questions. We'll also be opening this up, so if anyone has a question on the fly right now, please raise your hand. We'll get a mic over to you. But I have some prep questions because I hate just awkward silences. So first question is for the Ibotta presenters. So a question I get asked a lot is, how do you structure a data engineering team? Both operationally, like when do you choose to grow it? Do you embed data engineers with data scientists? Do you have a collective data engineering team? So I'd love if the two of you could kind of talk about your experiences at Ibotta, how that works for y'all, better or worse.
Sure. So we kind of have our own data engineering team, and we mostly, technically we sit on the Ibottalytics team. So we have done one great experiment. He's actually here. Eric went and worked with our client side team for 6 months as an embedded data engineer to build a distributed ledger system. They're actually both here who built it, which is pretty cool. And that actually worked out really, really well. And we've seen a lot of drive to have microservices architecture emitting events now. One of the things that I had on there in our architecture was this new service that basically takes these events and reads them off of SNF topics and streams and brings them into our data lake. So that's a new avenue for us to create microservices that are populating our data lake. And that was all made possible by getting that kind of data engineering philosophy into another team. Most of the time has been really spent in our core team building out this new data platform. That's not, all the work except for Eric. So for right now, we don't have too much experience other than that. Our team was started, about 15 months ago when Nate joined the team and originally John. Is that good? Anything else?
Yeah. Mike, do you want to add anything?
From a feature engineering perspective, I'd add that the closer that data science has sat to data engineering, the better things have gone, especially when our primary products are directly built off their products. It's really helpful to be able to yell at Steve when something breaks.
Yeah, I'm the Steve in that situation usually. Matt, we heard earlier that Ibotta started with a MySQL database and now has, is it petabytes? Am I saying that right? Yeah, petabytes of. I've always said PETA, and I know I feel really stupid. Petabytes of data in a data lake. I mean, that's maybe eradicating a data lake entirely is like Snowflake's goal. So you don't need to worry about that at all. Kind of just flexibly scale that. But as someone who works with companies to grow their data storage operations, when's the right time to make that transition from a database to a data warehouse to data lake?
I don't think there's necessarily a transition that needs to happen. More so they can all coexist, in the same environment, right? We could very much work with the data lake, right? S3 and Azure Blob Storage can create, great environments for the data lake, and then you move aggregated data sets into your data warehouse, to then do analytics on and create a, easily accessible, fast, performant, easily managed solution. So I don't think it's one or the other, or it's a progression or evolution of your environment. I think they can all coexist, together. And being that, Azure and Azure Blob and S3 are infinitely scalable, in relatively speaking, extremely cheap, right? You can, keep all of your data in there, whether you have 100 gigs of data or multiple petabytes of data, and pay for what you use. So I don't know if it's one or the other at all. I think they coexist together.
Cool. Good for it.
I definitely wouldn't say it's one or the other, but it starts with getting your ingest systems also pointing to an object store, getting raw data out there just to see what the hell you can do with it and play around with it and start getting a sandbox built out while you're running your other systems in parallel is really key. You know, you can never test all these new technologies like Spark and all these engines that we talked about unless you have that kind of immutable source of truth of that raw data. And so that's kind of, I'd say, where you want to consider is how can you get some of your data ingesting? And maybe it's just having a copy of historical data. It doesn't have to be your Kafka streams, but just starting out with some historical raw data and then playing around with it is a really good first step.
So, John, earlier we talked about spot instances and how you can save a lot of money using some of the advantages of auto scaling that Qubole offers. You know, some of the tools we talked about tonight, Snowflake, Qubole, others that we've mentioned, are all really exciting and really powerful for different data operations, but they're not cheap. So how do you ensure, what do you use to measure value creation for your customers?
Yeah, so one way of measuring value for your customers is how much you're spending, right? And one of the stories that we tell at Qubole is we want to have our customers be able to say, I'm spending smart, not necessarily spending less or spending more. I'm spending as smart as I possibly can, right? And the auto scaling, the ability to use spot instances, the ability to right size your workload is really key to that. One of the other ways that we talk about value to our customers is when our customers come to us, or they've been with us for a while, we actually look at how we're influencing their KPIs, whether it's revenue, cost, operations, CapEx, right? And that was one of the screens that I put up there was like, what's your data engineer to user ratio? What's your savings on spot? How is your data platform able to scale as your business grows, right? But above all, like we should be moving KPIs in a positive way.
Olin, you want to add to that?
So he was asking me about some TCO numbers about spot instances because we can show some pretty specific, not very objective examples about cost savings with that. But I think that goes beyond the point. One thing that I found really interesting actually between, you guys were all here at Ibotta when we kind of first were going into data science, and you guys tacked on to one business use case. A/B testing, super simple. You solved it. You showed the value of that. You measured that back to revenue to the company. And now it was like, okay, guys, clearly this is working. Clearly this operation is working. Now we need a system in place we got
Not my laptop, so I don't know how to stop that.
a ticking time bomb back here. But I found that to be really interesting, and Mike mentioned earlier too, like being really close with the engineering teams is critical. But I think that also goes with also being aligned with the product cycles too, being able to get product to understand how they can implement new features through how you guys can actually develop and produce them and what is capable of your team, as well as having really tangible evidence that you can go back to your executive and say, look, this is working. Let us go and spend R&D time on this because we've already shown new revenue here. And that's huge to tack on.
Yeah, absolutely.
Sure. I mean, that opens up a whole other can of worms, which is...
All right, we have 8 minutes and 40 seconds.
Cool. I'll toss it back to you then.
No, I don't know that that's actually going to shut down, but I hope not. Keep going.
I was just going to add that, I guess, to your point, Holden, when we prioritize initiatives, we, as a feature engineering team, we have to sort of evangelize our features and our skill set. And we've been doing a good job of that. And we've had a lot of success embedding in core squads that are having profound effects on the numbers we have on the wall over there, which are our KPIs. And every initiative, it has an estimated impact on those numbers, and that helps prioritize projects. So I'd say like it's kind of on our team to embed ourselves in that product process and communicate that value. But obviously without those data platforms, that wouldn't be a possibility.
So we've talked tonight a lot about some open source tools. Airflow was open sourced by Airbnb. Kafka was open sourced by, I believe, LinkedIn. And Presto was open sourced by Facebook. So these are all very powerful tools being used at scale by very large companies. But I've seen personally some companies, or as an engineer at some companies that are a little older, like 100-year-old Fortune 50 companies, adopting open source can still be kind of a sticky subject. So how do you see the role of open source in modern data engineering in both developing the feature set of the tooling, but also creating some barriers for adoption in enterprise use cases? This is an open question to everyone.
Yeah, so it's been interesting watching the open source community since the early 2000s. It was pretty niche. You were basically bidding your job on somebody else's software. But recently it's been more acceptable. We see inroads into larger, more mature organizations. A lot of what they want is they want functionality. Depending on the organization, they're willing to pay for it. But as costs get tighter, things like that, they're looking for something that provides the functionality they need for a price that's right. They also want the ability to have it supported. And if something goes really wrong with it, that they have somebody to yell at and come in and fix it for them. So they want that service behind it as well.
Yeah. So with open sourcing, there is a question of where do you run it? Because it just, it's out in the open. So you have Google Cloud Platform, you have AWS, you have Azure. Oh, again, open question to all of you. Are all cloud platforms created equal for data engineering?
I've only really worked on AWS, so I can't speak to that.
Anyone else?
Well, having just recently passed my Azure exam, I can talk about AWS and Azure.
Do you have any Microsoft swag you want to give out?
What's that?
Do you have any? You can paid here.
Yeah. So the clouds all offer very robust functionality. I think it comes down to what your ultimate goals are, and AWS you can build right from scratch. You're pretty much in the cloud. Azure has a really nice play for the hybrid cloud, so you don't have to decommission your on-prem. You can burst workloads to the cloud. You can use Active Directory, which if anybody's worked for a fairly large enterprise, Active Directory is probably one of the biggest things that tie all the users together. Yeah. And it also depends on which features you're looking for. If you're looking for streaming, things like that, those are pretty ubiquitous across clouds. But as you get more nuanced, that might drive you into one cloud versus another.
So Matt, Snowflake can run off of AWS and Azure, is that right? Awesome. Is there a reason why not Google, or at least not yet?
It's not yet.
Not yet. Okay.
Yeah, so we originally developed on top of AWS because 6 years ago, Amazon owned the cloud market. And as Azure has matured in its services, we felt comfortable enough to develop on top of Azure as well, because they caught up in a lot of core capabilities that Amazon had. In my opinion, Google is getting there. They have a little bit to go as well in their infrastructure. So again, there's some core capabilities that make Snowflake that we need those underlying services to have. And so they're getting there, and our goal is to be across all those three major cloud platforms. So it's on the roadmap. It is coming. TBD on timing, but we will then be the only true cloud data warehouse to be across any platform that you should choose, which will be unique.
Definitely. Speaking of timing, it appears we might have only 3 minutes left. We're not sure what's going to happen afterwards. So I'd love to open love to open questions up to the audience, to anyone who has questions, maybe during the presentation or one that's just come to you now. So I'll come out to you if you have a question. Anyone? Yes. Can we wait for the mic for the live stream? Sorry. Yeah. Here you go.
Since Airflow has been the theme of the evening, if each of you could add just one functionality to Airflow, what would it be?
That's a good question.
I am unqualified to answer that question.
For the record, we tweeted this out, and some of the Airflow core committers liked it. So I know some of them might be watching right now. So this is perfect.
I would just ask for, if I could have anything, I would ask for subdags to work. And backfill functionality, but that's two things.
That's so true. It hurts.
I don't have a huge dog in this fight. I guess just better monitoring really is where I would, just more listeners on there.
Do you see some of your customers like rolling their own monitoring or incorporating other tooling?
Yeah.
What does that typically look like? What is it, like an elk stack or?
I mean, we have Sumo Logic integrated with ours. It makes parsing tons and tons of logs with their log reduce really easy. Shout out to them. They're not here or anything, but it is nice when you're searching for a problem that's maybe happened many, many times. I guess kind of in that vein, better logging in Airflow. Sometimes we've had some errors where it's like the error is just like it just says oops, and there's some ASCII, just a little more polish. Honestly, I think it's going great. If anyone's looks at Airflow 1.10, there's a lot of great features, including like role-based access control, which is really useful, especially that's one of the things we really wanted is to be able to give access to our Airflow to more, consumers so they can go see if things are still running or if they're not done yet without them having the ability to actually break our stuff. So that's pretty important. And I'm looking forward to that.
Yeah, so I'd probably say monitoring and the ability to efficiently clear out tags and run so that you can rerun them. We definitely run into some areas where you have very complex tags that have a lot of dependencies, and kind of the rollback and cleaning out of the database has some issues with that.
Yeah, I think 1.10 with the role-based controls, and if the experimental API becomes officially supported, being able to clear out old DAGs would help a lot. Great. All right. Any other questions? Any topic at all? No? Okay. That's fine. I have more questions. The most common question that people asked when they were RSVPing was, how do you get into data engineering? What's the tools? What's the, like any curriculum or online? Steve?
Okay. Mine's just kind of funny.